In this video, we'll be looking at design patterns. So what are design patterns? So design patterns are nothing but descriptions of how objects and classes should communicate with each other to solve a general design problem in a particular context. Right? So as we saw earlier, design patterns have evolved over many years, and several experienced developers realize that these patterns appear again and again in code, and hence these patterns have been generalized, and these descriptions are known as design patterns. So what are elements of a design pattern? So first, we need to identify the problem for which a particular design pattern can be applied to. So we need to know when to apply the design pattern and in what context, right? So that is the first thing we need to know. Then we apply the design pattern that forms part of our solution. And this solution, it describes the elements that make up the design. So what are the relationships between classes, between objects? How do they collaborate with each other? So these are different aspects of the solution. And this solution, it serves as a template, right, which can be applied in different situations. And finally, when we apply a design pattern, it has certain consequences, right? We need to understand what the trade-offs are, what the costs are, what the benefits are, and weigh in whether we actually need to apply the design pattern or not in a particular context. Now that we know what the elements of a design pattern are, let's look at certain types of design patterns. So there are three types of design patterns. One is known as a creational design pattern. It is used during the process of object creation, right? So whenever we want to create objects in certain situations, certain creational design patterns can be used, and this will give us more flexibility as well as help us reuse existing code. We will look at examples of creational design patterns. Another type of design pattern is known as the structural design pattern. So structural design patterns, it explains how we can assemble objects and classes into larger structures, again with the aim of making our code more flexible and efficient. And the third type of design patterns are known as behavioral design patterns. These patterns ensure that there is effective communication between objects and classes, as well as it ensures that the responsibility between objects are distributed properly. Right? We will be looking at examples of each of these types of design patterns. Now that we have seen the different types of design patterns, in this video we'll be looking at two types of creational design patterns, the factory design pattern and the builder design pattern. So let's look at the factory design pattern first. So let's take an example of the seller portal itself. And let's say I want to implement a functionality where I need to deliver a package using a particular courier service. So I need to deliver a package using a particular courier service. So looking at this functionality, you realize that you will need two objects or two classes. One is the delivery, which delivers the package, right, using a particular courier service. So courier forms another class, and we see that there is an association between delivery and courier. So the delivery class has a method called deliver, which takes courier as an argument. So let's see how we can implement this functionality. So this is a simple code, right, which implements this functionality. So as we saw, we have two classes, a delivery class, which has a method called deliver, which takes courier object as an argument. Courier is another class which has certain parameters and certain methods, right? And what we'll do in the main method is we create a courier object, right? And we create a delivery object, and the delivery object calls the deliver method, which takes courier as an argument, right? And now if we run this code, yeah, so it prints certain messages. So delivered via National Courier Service within India, which is part of the deliver method. So now let's say you have been delivering couriers nationally within India. Now let's say certain products have become very popular and you want to deliver it internationally. You want to deliver it outside India. So you would require other types of courier services, right? International couriers, and they function, or the functionality for an international courier might be slightly different, right? The delivery also has a separate process. So that would mean you need to make some changes in either the delivery and the courier classes, right? So let's reflect on this for a moment. What changes will you make in the delivery class and the courier class in order to extend the functionality of sending couriers internationally as well? You can pause this video and think about what changes you can make before proceeding. Alright, so what changes will you make to include the functionality of adding, let's say, international couriers? So one way to do it might be to set the courier type to the type of courier, right? So let's say it is national, then courier type is national. If it is international, then courier type is international. And in the deliver method, we can check the type of courier. So if the courier type is national, right, then we can say, then we can apply the logic of how we can deliver it nationally. Otherwise else, that would mean it's an international courier, and then we write the logic for how we can deliver something international. But if you notice, this is actually violating one of the solid guidelines which we saw earlier. Can you think of which guideline it is violating? So this code is actually violating the open close principle, right? So which states that an object or a class should be open for extension, but it should be closed for modification. So in this case, you can see that we are actually modifying this class, whereas we should have been extending the functionality. So the factory design method helps us do that in an effective manner. So let's see how we can do that. So recall that this was our code earlier, right? And I need to extend this functionality to deliver packages internationally as well. So in the factory design pattern, what I will do is I will replace direct object construction calls with calls to a special factory method. Okay, so what does this mean? Let's look at our example again. So this was our code earlier, right? And now after we apply the factory design pattern, what we will first do is make these delivery and courier classes abstract, right? And based on the type of courier we want to send, we will create separate classes which extend the courier class, right? So we'll create a class called national courier, we'll create another class called international courier, right? Which corresponds to sending something nationally and internationally. And in addition, we will also create classes which extend the delivery class. One which corresponds to national delivery, another which corresponds to international delivery. And in this case, we have an additional method called create courier, which returns a courier object, right? So the delivery class has a creator method which creates a or which returns a courier object. And so the national delivery class will return a national courier. The create courier method will return a national courier object, and similarly the international delivery class has a method called create courier which returns an international courier object, right? So the responsibility of creating objects has now been delegated to these classes, the national delivery and the international delivery, and to a specific method known as the factory method. So in this case, the create courier method is known as a factory method, which actually creates the courier objects, the appropriate courier object based on our condition. So now let's see how we can implement the factory design pattern in our code. So recall that we had a class called delivery, another class called courier, and we created a courier object, right? And we passed that to the delivery object D, right? So in the factory design pattern, what we'll do is we will create an abstract or make this class as abstract, the delivery class as abstract, and we create a factory method called create courier, which is an abstract method here, which is responsible for returning or creating the appropriate courier object, right? So we can make the courier class also abstract, and for each type of courier, let's say we want a national courier, the national courier class can extend the courier class, and we can have functionality specific to national courier services. Similarly, the international courier can extend the courier class, and we can have functionality specific to international couriers, right? And for each of these courier types, we have the corresponding delivery classes, right? So in this case, the national delivery, it extends the abstract class delivery, and hence we are also extending we are providing the implementation of the abstract class create courier. And the factory method, so create courier is the factory method, right, which will return a courier of type national courier. Similarly, international delivery, it extends delivery, and similarly it implements the factory method, and in this case it returns a courier of type international courier. So it creates a new international courier object. Now let's look at the main method. Now that we have seen the abstract classes and the other types of classes, let's see what's happening in the main method. So in the main method, as opposed to before we are creating a courier object in the main method, right? Whereas here what we are doing is we are creating a delivery object D, right? And delegating the courier object creation to the factory method, right? So D is of type international delivery, and when we call d.createCourier, it is actually calling the international delivery classes deliver method, right? Sorry, create courier method, and it is returning an international courier object, right? So to reiterate, what we are doing here is we are creating a delivery object, and the delivery object calls the factory method create courier in this case. So create courier returns a courier object of type international courier, right? And this is then passed to the deliver method of the deliver object, right? So what is the advantage of using this factory design method is that now let's say I want to extend my courier services to, let's say, local couriers, right? So all that I have to do is create the appropriate classes and call the factory method create courier, call the appropriate factory method, and it will create the courier service for me, the courier object for me. So in this way, it makes the code more understandable and more extendable. Now that we have seen what the factory design pattern is, let's look at some of the pros and cons. So what are the pros? What are the advantages of using this design pattern? One is that this helps us follow the single responsibility principle. So recall that single responsibility means that each class has a single functionality or responsibility to perform. And second, it follows the open-close principle, which states that classes should be open to extension but closed for modification. So let's examine these with the code which we have, right? So before implementing the factory pattern, let's say I wanted to include national, international, as well as local courier services. I would have to do that in the courier class itself, right? So in that way, the courier class is taking additional functionalities and responsibilities. Whereas here, I create classes for each type of courier service, right? As well as I delegate creation of these to the factory methods of other classes, right? So in that way, each class is performing a particular functionality. And now if I want to extend the courier services to additional types, let's say local delivery, I need not modify existing classes. I just need to add additional classes to implement the functionality. So in this way, we see that the factory design pattern encourages single responsibility as well as the open-close principle. Now, what are some cons of using this design pattern? So you might have observed that the code can become complicated, right? There can be a lot of new subclasses which are added, and this can make the code a little more difficult to understand. So hence we need to decide or make a trade-off as to whether we need to apply this factory design pattern or not based on the context in which we are writing the code. Now let's look at another creational design pattern known as the builder design pattern. So let's take an example. So let's say I have a book class and I need to create a book object with some mandatory parameters and some other optional parameters. So in this case, let's say that ISBN title and cost are mandatory, whereas author, published and description are optional fields, right? So in order to create such book objects, I need to call different types of constructors, right? So let's see how we can implement this. So in the code here, we see that we have a class called book, right, which has some mandatory parameters as well as some optional parameters. And this is a constructor which includes all of the parameters. But let's say I just want the ISBN title and cost. This is another constructor which can be used. And let's say I want only the description, the author and the year of publishing is null, then I can use this. And if the description alone is null, then I can use this constructor. So are you seeing the issue with this? So based on the parameters which we have, we need to create different types of constructors for different combinations, right? And this is known as telescoping constructors. You create multiple types of constructors, and this can make the code a little complicated, right? So let's see how we can use the builder design pattern to solve this problem. So the builder design pattern tells us to extract the object construction code out of its own class, right? So we separate out the object construction code and we move it to a separate object known as a builder object, right? So if we take the example of the book class, so we create another class called builder, which has the same fields as the book class, right? And in addition to that, it has methods like author. So this method is nothing but the method which initializes the author field. The published method is nothing but the method which initializes the published field, and the same for description. So for each of the optional parameters, we have additional methods, right, which initialize those fields, and we have a build method which finally builds the object and returns a book. Now let's look at how we can implement the builder design pattern. So this is the code for how we can implement the builder design pattern. So as you can see, we have the same class book, right, with the mandatory as well as optional parameters. In addition to that, we create another static class called as builder, which has the same parameters, the mandatory as well as the optional parameters. And we create a constructor called builder, which takes the mandatory parameters, right? And then we create methods which build individual parameters. So for example, this method called author, we can rename it to something else like author builder, for example. So author builder just takes a string and assigns it the value of author. The same for published year and description as well, right? And we have the build method, right, which returns the book object, right? And here we can see that it is calling a constructor, and we will look at what this constructor is below. So the additional constructors which were there earlier, all those have been removed, and it's replaced by a single book constructor, right, which takes the builder object as input and assigns the values for each parameter, right? To reiterate, we see that we have the book class with the optional, mandatory and optional parameters. We create another builder class with the same parameters. We create a constructor for the builder which has the mandatory parameters, and individual functions for the other optional parameters. And we have the build function which returns a new book object. And we remove all the other constructors for the book class, and we keep a single constructor which takes the builder as an input parameter and assigns values for each of the fields. And now in our main method, we see that we are creating a new book object, right? And we are calling the builder constructor which initializes the mandatory parameters, right? So this function is this one, right? So ISBN, title and cost are initialized, and then we call the individual functions, right? So let's say if I want to assign author, published as well as description fields, I call individual methods which are part of the builder object, right? And finally, I call the build function, right? So remember that the build function, it will return the book object, and that gets assigned to B1, right? So if you see book 2, in this case, we are just creating the description for the book, whereas the author and the published year is null, right? So we just need to call the description function and the build function, and build will return a book object with description set to this and author and published year set to null. So what are the pros and cons of the builder design pattern? So the pros are, one, it helps us construct objects step by step, right? So we saw that we can construct this book object by initializing each parameter, right? So as opposed to calling lengthy constructors, right? And the other advantage is that it follows the single responsibility principle of separating the task of object creation with other responsibilities, right? So the builder class takes care of building the object, and the actual object now can focus on other aspects required of that class. Now, what are some drawbacks or disadvantages of this design pattern? Well, the key disadvantage is that the code may become more complicated, right? So as we saw, we needed to create another builder class with the same parameters, right? And additional functions as well. And if you feel that in your code you do not have many mandatory and optional parameters, then it might be okay to not use this design pattern.